Ramadhani Putri. You can call me Rena. I'm from Department Physics 2019. In this video, I will description about the map of physics. Physics is a hex subject that covers many different topics, going from galaxy in the deep of space right down to subatomic particles. And if you don't already know physics, it's difficult sometimes to see how all these different subjects are related to each other. This is my attempt to show that in a map, the map of physics. I hope you enjoy it. Physics can be broadly broken down into three main parts: classical physics, quantum physics, and relativity. We'll start with classical physics, and a good person to start with is Isaac Newton. His law of motion describes how everything made of matter moves about. And his law of universal generation set together the motion of planets in the sky with the falling of objects on Earth into one elegant and general gravitation. He also invented calculus, a supremely powerful mathematical tool which has been used over the centuries to define new physics. Calculus is really part of mathematics, but physics and mathematics are inseparable. Math is a length of physics. You can imagine it like the bedrock that the world of physics is built from. Newton also made strides in the field of optics, which is the physics of light and how it travels through different materials. It explains refraction seen in prisms and lenses, which are used to focus light in telescopes, microscopes, and cameras. Telescopes enable us to peer into the deep of space and observe the wide array of objects. There and develop astrophysics and cosmology. Optics is closely related to theory of waves, which is basically how energy can travel through the structure of a medium, like ripples on the surface of a pond or sound through the air. Light does not need a medium to travel through. It can travel through the vacuum of space, but it still follows the same principle as all waves, namely reflection, refraction, and diffraction. This leads us to electromagnetism, the description of magnet, electricity, or more generally, electric and magnetic field. It was a physicist called James Clerk Maxwell who discovered that these are two experts of the same thing and derived of wonderfully elegant rules of electromagnetism. In theory, the light was an electromagnetic wave. Electromagnetism also explains all of electricity. Jumping back a little bit, classical mechanics is related to Newton's laws and cover the property and motion of solid objects, how they move when force hit them, what happens when they are joined together, like in gear or building, or big. Fluid mechanics is the description of the flow of liquid and gas. Using fluid mechanics, you can work out how much lift is generated from an aeroplane's wing, or how aerodynamic a car is. Fluid mechanics is notoriously difficult, mostly because motion of thin things, like molecules, get really completed really fast, which leads us to chaos theory. Chaos theory is the description of large complex systems and how small difference in initial conditions can lead to very different final outcomes. Thermodynamics is the description of energy and how it passes from one form to another. It also includes entropy, which is a measure of order and disorder, and basically tell you how useful different kinds of energy are. Energy is fundamental property to physics. Although I have written energy here, I should have written it everywhere on steep map because everything has energy. So that's it all of classical physics, the picture of the universe we had around the year 1900. It's obvious we live in the universe where everything runs sort of like clockwork. If you could measure everything accurately, knock the future was get of predetermined. However, not everything was solved. There was just a fail of hole in experiment that hinted at something more. The orbit of Mercury was likely to face, and some strange things happened. On the smallest scales with electrons and like which were all unexplained. Physics it at the time thought they would solve and explain this problem soon enough, but looking at them they unraveled the new domains of relativity and quantum physics, and turned our understanding of the universe complete on this head. Albert Einstein was the genius who developed the theory of special and general relativity. Special relativity predicts that the speed of light is constant for all observed, which means that when you travel really fast, stuff starts happening like time, snow, slowing down. It also states that the energy and matter are different aspects of the same thing, through the famous formula E equals mc squared. General relativity says that space and time are part of the same public called spacetime, and that the force of gravity comes from objects beyond spacetime, making other objects fall toward them, while relativity describes the very big. Other physics is where busy outward on the very small. In the world of quantum physics, atomic theory problems the nature of the atom, and more detailed description of the atom were developed, from a thin sphere to electron orbit to energy levels, and then to the electrons being wave-like change distribution. Condensed matter physics describes the quantum physics of many atoms together in solid and liquid, and is where many great technologies have come from, like computer, laser, and quantum information kind. Nuclear physics describes how the nucleus of atoms behave, and explains radiation, nuclear fission, the splitting of the atom used in our nuclear power plant, and nuclear fission, which takes place in the sun and will have full soon be harnessed here on Earth. Particle physics probes even deeper to find the fundamentals of atomic particles that everything is made of and are described in the standard model of particle physics. Quantum field theory captures all of quantum physics and combines it with the special theory of relativity and is the best description of the universe we have. Unfortunately, quantum field theory does not include gravity, and so physics is don't know how to join together quantum physics and the general theory of relativity, leading to the giant case of ignorance. One day in the future, we hope to close these camps and come up with a theory for all of physics. We call it quantum gravity, and there are many attempts to do this. Some examples are string theory of loop, quantum gravity, and there is many more. But quantum gravity is not the only thing we observe but don't understand. There are also the major puzzle of dark energy and dark matter, which seem to make up 95% of the universe. So all of our physics only really describes 5% of what we know about the everything else. At the moment is a mystery. There are many other mysteries out there like the Big Bang and no doubt there are things but that we don't even know that we don't know. We get to the lovely code which float over all of physics philosophy. All track many PC is make fun of philosophy. It is the big philosophical question that motivate a lot of physics like what is the fundamental nature of reality? How come the universe even exists? Do we have free will? If we are just made of physics? Or how do we know that's the way that we do physics and science actual gets to the fundamentals of the universe? And just why is all of physics like the way it is? Well, those are the big questions, ones which we may or may never answer, but that is no reason to give up trying. After all, physics is are not quitters, and that was the map of physics. Okay guys, so that's the end. Thanks for watching the video. I hope you enjoy it. See you!